Hi everyone, long time no see and welcome to another video, and today we're going to be talking about a tool that I made to sort of show you the different types of decompiler tools that you can use in your projects to be able to decompile C#, decompile .NET in general, and use sort of other things to decompile stuff. So if you know a bit about me, I was involved in making a lot of compilers are surprising infographics on my webpage, and I post them on Twitter and various places as well. And one of the things that I'm using to be able to do those is the tools that I've sort of written for myself. So anytime you sort of want to have a good, for example, the compilation output, the thing that you can sort of use is a primary tool is SharpLab, and I was using SharpLab as well. So as you can see, there's this web page with SharpLab, and what you can do is you can sort of type code, and it will sort of, give you your assembly output, plus it can do a lot of different things, right? So as you can tell, it generated an assembly output, and I was using this tool to make one of my first infographics, and this is a really good tool because it's an online tool. It has a lot of features and whatnot. But today I wanted to sort of talk to you about my own tool, because my own tool is sort of working almost in the same fashion as SharpLab. The only difference is that this is an offline tool, and it's one of its biggest weaknesses and strengths, because if you're doing a lecture, anytime you're using sort of a web-based tool, it's the chances are something's gonna happen, website's gonna crash, you're gonna have a slowdown, and it's not gonna work. So that's why I sort of did my own, and I wanted to sort of have much more features, and the features should be driven in this sort of fashion, where what we're gonna do is we're gonna have it be a lecturer tool first and everything else second. So all of the features are sort of centered around that. And let me show you what I mean, really, right? So let's go here and let's sort of start the tool, and we're gonna pass some commands, and it's gonna sort of run the C# decompiler. It's gonna actually run a Go decompiler as well, because it supports multiple languages, right? What I mean by having this tool to be able to do lecturing, right? So you don't need to even type a class, you don't need to do anything else with this tool. Each time you sort of just write a piece of code, it doesn't have to be private, public, whatever. Each time you write a function, it's gonna display stuff on the screen, right? So that's the first change that is different than SharpLab, I guess, right? The second thing is that whatever you sort of trying to do something, it has shorthands for a lot of different things, right? So again, no usings, no nothing. It will just do implicit using. If you need some usings that this tool doesn't have, you can of course type using XYZ, and it's gonna work, right? But regardless, this is a tool to be able to sort of show you how stuff decompiles and how to sort of reason about it as well, because we have certain attributes. But let me show you a bit a complicated function. So let's just say that I'm gonna have a bunch of these simple things in this method, and I'm gonna type it in, and let me return X. And as you can tell, it will do instruction counts, and it's gonna compute the code size and all of that good stuff, right? But we can do a bit more with this. So what we can do is we can have custom attributes that will do various things. So for example, one of the attributes is show ASM docs. And now, as you can tell, it will sort of show you roughly speaking what happens at high level. So you know that this is an assignment, this is a ++ operator, this is a return, and all of that stuff is going to be sort of highlighted here as well. So you can now configure it a bit. You can set the offset to 50, for example, and offset. That's why it didn't work. Let's do it 30. ish, right? 35, it's going to be a good metric. So now, as you can see, it's like neatly sort of displayed, right? Let's do 32. What else we can do here? So what we can do here is, if we say that, for example, if x is equals to 1, then let's return 1. Then, as you can tell, it's gonna do like this sort of jump here, and that jump is going to be sort of followed by a if statement, and that if statement is gonna be present in the code here as well. And you can do another thing which is pretty cool. You can have another attribute saying like show guide, and if we are gonna show guides, then as you can see right now, it will sort of draw these handy sort of instructions, which will tell you where the jump is gonna be sort of heading, and what else. You're gonna get this sort of nice arrow here. And like I said, those are the features that make this tool into this sort of display tool, right? So you see a full big address. Maybe that's not what you want to show, because that actually takes a lot of screen space. So maybe you want to format this slightly differently. So you can do like short addresses, and you can do like short it by, for example, 2, right? So it's shorter. The coloring is a little bit messed up, so I'm still working on it. But if you shorten it by like 4, then as you can see, it is better for like display purposes, right? I tend to leave it on 8, because those methods that I sort of show in these like compiler lectures or infographics don't need to be longer than like 4 characters in the address space, right? So what's going to happen if we sort of complicate this a little bit, right? So let's do a for loop, and let's complicate this, and let's see how the guide system is sort of working to help us understand what's going to go, how it's going to sort of behave, right? And what sort of things can we sort of expect. So if we're going to do this for loop, and then as you can tell, we have like a forward jump, which means that we're gonna jump down. This is usually an if statement. It's a good practice to like leave it as an if statement. And we have a backward jump, which means that probably this is a for loop, because we're gonna spin around, right? So this is sort of the presentation that we're sort of going in for, and it's designed to show you what's happening in code, even if you don't understand assembly code at all. Those things are all sort of like helpful to you, right? So that's why this tool is sort of being built to, for example, do infographics around these sort of surprising things that compilers generate. And the other thing is like to do like lectures about compilers. So another thing that we can sort of do, if we can like do like another function, and we're gonna call rm function with some arguments, like we're gonna pass, for example, 10, then it's gonna make a call here, and we have now 2 functions, right? So if we, for example, want to inline these 2, and we don't want to have this call here, usually there's this complicated attribute in C# where you have like method implementation options, aggressive inlining, or like no inlining, right? So in order to not type all of this, right? Because you might have a typo, you might not remember how to sort of call this. I've designed a bunch of like shorthands. So for example, we have a custom attribute called inline, and it will do the same thing. So now you sort of see that it's gonna inline your code here as well. So inlining is the process where you take one function and like put it into the other function, but you're gonna do some morphing and optimizations along the way. So those 2 functions are not gonna be like identical, right? Though this code is not going to be precisely the same, but it's gonna be inline. So the whole logic of one method is gonna be put into another method, but optimizations and assembly instructions might be completely different. So this is to sort of show you that, and sometimes things will automatic inline. So you have another attribute called no inline. So this will absolutely prevent inlining. So it's another thing that actually gets translated into the C# code, this method implementation attribute, right? So what else can we do here? So there's some interesting stuff. We can do for example, an attribute called run. And as you might expect, a run attribute will actually run the code. It will not do anything with it because there's nothing yet, right? But if we're gonna run the code, we can actually print stuff. So we have this print method now, and we can do like, printing as well. So we can, let's just say that we're gonna have an x variable, and we're gonna pass in the x, and then we're gonna see what's the value of x, and it's gonna tell us, right? So it's doing a bunch of trickery, a bunch of like rewriting the functions to be able to even capture that name and do whatnot. But it's sometimes useful for, again, presentation purposes. But the most useful thing that you can sort of do here in this code, and I've been using it a lot lately, is the benchmark attribute. So you can have this attribute called bench, and if we run it, it's gonna just default the parameters, and it's not gonna do a lot because it will run the method and it will sort of do a 1000 calls, which is a warm-up phase, and then it's just gonna do 1000 calls, which is like the measuring phase. Obviously, it measures in milliseconds, so this takes no time at all, so it takes 0 milliseconds, but in order to be able to sort of see some benchmarks, we can tweak it. So what we can do here is we can say like run count equals some big number, right? And if we change the run count, it's still gonna be 0, but the more we add, the worse it's gonna become, because it's not measuring the mean of the method, it's measuring a total running time of this many sort of calls, right? So this is a very simple benchmark that you can do. I have a plan to sort of exchange benchmarks and like hook up benchmark.net at some point and whatnot, right? But for now, if we're doing these things with assembly code and methods, and we're trying to show up like the complete dumpster fire, which is some types of optimizations, this benchmark is enough to be able to show it. All right, so those were the most important features to sort of make infographics, and this of course is open source. It is being still under development. It has no release. You have to compile it from code, but there's documentation, there's guides. The program will guide you if you like mess up the input arguments for this sort of tool, and it will do a correct job, hopefully. If not, we can always improve it, right? So that's one of the bits that we can do right now. The other bit is we can actually compile into multiple runtimes, and we can actually compile in multiple languages. So another language that we can sort of compile to is Go. Oh, and if we're sort of compiling in C#, of course we can see IL. It's gonna write to this IL file as well. IL still needs some like color coding, still needs some things, because if we're gonna put in the like run attribute, it's gonna actually dump all of the hidden stuff, like those attributes and those benchmarks, into IL. That needs to be cleaned up, but you can sort of find your method here as well and check the IL, right? It's not very practical yet, but it's gonna get practical soon. So this is our end method that's gonna call the M method, and this is our method. So it's like full IL. So that's one of the things that you can do in C#. You can also do something that's really cool and interesting, but it's still being like heavily developed, is that you don't need to write C# code specifically. You can actually write IL code and compile that to C# and compile that to decompile that to assembly code. So you can do like crazy stuff, like for example double boxing. So you can box a reference type and see what happens. So this bit is to be able to do like these sort of crazy experiments, because IL has a lot of instructions. A lot of them aren't even sort of present in C#. C# will never output certain instructions, and it will never sort of output certain combinations of instructions, although they might be valid or not. Sometimes they're unidentified, and the compiler will still sort of take them and do something with them, and you can test what sort of things will it do, right? So like I said, I've tested like what's going to happen if we box a box type. You can totally do it and it's going to do something, right? But it's not going to crash. I can tell you that, right? So that's interesting in some capacity. So one of the things that I sort of almost missed in this video is the ability to be able to do layouts. So not only you can sort of decompile methods, show IL, show like a lot of things, run them and benchmark them, you can also do layouts. So if you have a custom type like a class or a struct, it's going to show you a custom layout, which is pretty useful if you're trying to sort of lay out your stuff in memory because you're trying to see what the performance is going to be of that, right? This feature is still experimental, it's still in development, it sometimes crashes, but it's going to get better with time, right? So let's create like a public class called S, for example, and let's do public boolean A, and let's just save it, right? So as you can see, it has its memory layout, it's gonna post its size, and it's gonna post its like range, right? So if you add like an int called B now and save it, you can see that it sort of switched places. So the int is first because of the compiler packing, and you can sort of do these things and check out the sizes of things. So for example, if you're ever wondered what's the size and sort of layouts of empty structs, so let's do like struct empty, for example, it's going to be completely empty, right? So the size is 1, and you can see some interesting messaging here that the size is estimated, because the way that we sort of have to estimate the struct size is we're actually putting it on the heap, not on the stack, because a struct can live in registers, it can live on the stack, and it can actually live on the heap. So it can live in a lot of places, and it's difficult to judge how it's gonna sort of end up. Then it's just easier to box it and then do some estimation analysis and then post the size, which should be mostly correct. Because it follows sort of the rules of the compiler, right? So this is another feature which is really interesting. It's still like early in development, but you can probably you can use this and have fun, right? So moving on. Okay, moving to Go. So in Go, we now have this very simple sort of decompiler output, which the Go compiler actually provides for us almost for free. You just need to call the right tool. But it's not very sort of like pretty, right? And it sort of crashes because it just cannot find the correct file. But let's do like function, let's try it out. Let's do it like that, and let's do like x plus equals 1. So it didn't crash this time around, and as you can tell, it's the Go assembly output. It's not x86 assembly code, it's it's IL, but the Go sort of intermediate representation is very close to the metal. So the Go compiler will not do most of the optimization. So what you sort of see happening here is almost the same that you're gonna get in x86. So I didn't sort of bother yet to actually look up the correct assembly code, because most of the time it's just changing names. It's not like doing, large scale optimization. So all of the optimizations already happened. So if they don't happen here, the chances are they're not going to happen in x86 at all, right? But as you can tell, it still works. The code is a little bit like messy, right? But we can sort of do like if x is equal to 1, then let's like return 1. Otherwise, let's return x. Of course, we need to sort of modify this function now to return something else. But as you can tell, it did its job. Go has this neat feature which it's gonna map instructions to like code. So when I'm going to be sort of updating this this Go decompiler, I'm gonna do certain things with it, which is gonna be interesting. We're gonna add guides. Right now, there's no guides here, but we're gonna do it. And we're gonna sort of clean this up because we don't need most of this information. We would just want probably to have this and maybe the header of the function and not much else, right? So there's some stuff to do, but we're gonna get there. And in terms of architecture, I guess we're gonna cover that in a separate video if you would like to see like the architecture, because I tend to sort of have this different coding style than most people, and you might find that interesting. So that's it for this video, and I hope that this tool is going to be helpful for you. Leave a like, subscribe if you will. And if there's, if you want to see more, then just type it in the comments and I'm gonna make another one where I'm going to show you some like features in code and some ideas and some like design choices that I made. Some of them are correct, some of them are incorrect, because I just found out that some of the stuff is not possible to do with the .NET Decompiler, because I have to like change the design completely, but it is what it is. So thank you for watching and see you next time. Bye.